Hello, everybody. Today, we will cover regression analysis. Before we go chapter lecture, let me ask you if you did something for your team project. Is there any progress?
Dr. Kim.
For group 3, we are setting up our introduction.
Okay.
So,
okay, who first?
Go ahead, Chi. Go ahead. You go ahead.
Thanks. So for group 3, we set up our introduction.
Mm-hmm.
I don't know if you want to look at it.
Email me, then I will look at it, and then maybe next class I will give you a comment.
All right, that's nice.
Mm-hmm.
I will. Thanks.
Okay, how about Lizeth?
Yeah, so we were able to do to work on a couple of things. So of course, introduction we have that, but we also want to show you like some data that we organize and that we have in place. So maybe you will be able to help us what to do with it next. So I was able to do kind of like some charts and to see the difference and everything, but still it would be good for us if you can give us, to give us more guidance.
Okay, let me ask now, what kind of data?
Do you want me to show you?
Yeah, okay, good.
Okay, let me see.
I will make it, let you share. Okay, you can share your data.
Okay. It's not letting me yet. Okay.
Yes.
All right, so let me see this one here. Where do you go? Oh, my computer froze. There you go. Okay.
Okay.
All right. So
it's
this
coming.
is yeah. So this is what we have. We have downloaded this information from the census, and basically is letting us know, like, the electronic shopping and mail order houses, and this is millions of dollars. Okay. As you can see, we have all the information from previous years as well as each month. So basically what I did here is because we want to see the difference between, is related to COVID. So we want to see the difference between 2019 and 2020 for the same time of the year. So I have created kind of like this, let me see, move this here. Okay, so I have created like a, and this is basically, you can see the difference here, how much compare with prior year, how much e-commerce grew during pandemic. So it's a very big change. And also here, actually, it tells like difference between this one, the blue one, is the increase between 2019 to 2020 for the same time period. So in January, the increase was between 2019 to 2020 was 9.93. As you can see, March, April, May, it was like the increase was super, super big. And then in June, kind of decrease a little bit and decrease a little bit, but still is higher than prior years. That's one thing. This other one that we have is this one here.
So this is, you said is e-commerce?
Yes.
Data?
Correct. Yes.
So
Dr. Kim, I don't know if it's my computer, but I cannot hear you anything.
Let me see.
Okay, now you're good.
Yeah. So the blue line, the e-commerce from 2019 to 2020.
Mm-hmm.
So compared to last year, so it is now 1, 2, 3, 4, 5, 6, 7, 8 months.
Yeah, but I can have more. I mean, of course, for 2020. Go ahead.
Yeah, it's the same month, 2000.
Yes.
From 2019 to 20, and then 18 to 19.
Correct. Both months.
Okay.
Yeah, at the same time. Yeah.
From January to August.
To August. And you selected until August because 2020 only has data until August. So that's why I selected from 2019 until August.
So from this data, we can see because of pandemic, people prefer not to go the market or buy something in person. So using more online. Yeah, we can see. Okay, very good data. And then, so your kind of expectation is pandemic increase online transaction.
Correct.
Yeah.
Yes.
Yeah. Very obvious.
Yes, it
is.
is.
And then how can you explain the blue line was 35%, but the later decrease. Can you explain why?
I believe because until here, remember that many states were still under, like a stay-at-home order. And then by June, July, and August, those restrictions start to be less and less. So that's why more people were able to go out and buy, and shoppings were open, and so that's why people were able to go to retailers and store retailers and buy.
Good
and
explain. Yes. Yeah, good explain. Okay. So far so good. So keep going.
Nice, sir. Okay.
Then later,
thank you very much.
If when you have a team meeting, then if you need me, my comment, then invite me. Then I can join and then work together.
We'll do, Dr. Kim.
Okay.
Yes.
Good. Yeah. Good.
All right.
Okay. Any other team progress like this? By the way, Elisa, the pain is okay? You sound.
Sorry, I could not open it. Yes, I am doing okay right now.
Okay, good. Okay, anytime if you have a progress, and then if you need my help, then anytime ask me. Then if you have a team meeting, then invite me, then I will join you, okay? Okay, let's go. Regression analysis. Last Wednesday, we covered some the same part in operations management, forecasting. But here, this time, we may use this regression analysis for the forecasting, and then we can use this regression analysis for the analyze data. Last week, earlier last week, we received from the journal, we submitted our one of our research paper with my friends. Came back now for revision. So last Friday, Saturday night, almost all night long with my friend in Zoom meeting. We revised that paper, and then last Sunday, yesterday, early in the morning, we submit. The paper, I used this regression analysis for data analysis. So this regression analysis is one of the most using research tool for data analysis. Okay, regression analysis, if we have data like Y and X, dependent variable, and then independent variable. So using independent variable, we can forecast or predict Y dependent variable. So enables you to develop a model to predict the values of a numerical variable based on the value of other variables. So using X variable, independent variable, and using independent variable, predict the dependent variable. And like this, and then the relationship between the variable is linear. If it is not linear, then we use other regression analysis technique, that is log linear kind of regression analysis. So usually the basic regression analysis is find this linear line using X variable and Y variable. So slope and then intercept. If we use formula, then we can use this formula to determine slope and intercept. So here intercept and then the slope of this equation. So using a least square principle, that means if we have data, like past data, then using formula, then we can get many different equation. Among them, the distance between forecasted equation and actual, try to minimize. Then we can get formula to get slope and intercept. But we will use Excel, and here example data. So open this file. This file is on Moodle. So if we have a data set like this, simple example, study hour and exam score, we can assume more longer study hour than exam score higher. So using this data. So between two variables, study hour and then exam score. So more study hour, then maybe higher exam score. So I say like move first and then follow, then moving first, that is X variable, and then following is Y variable. So we can use many different tools, but first let's use the basic Excel data analysis tool. So click this one, and then find the regression. This one, then click OK. Then input wide range. So exam score will be Y variable. Then study hour moving first, that will be X variable. And then I include in the label, so check label. Then I will show the output here, then okay. So output, based on this output, we can develop equation. So here intercept, and then this one is slope. So we can make equation intercept 49.477. And then slope is, this one is positive, so plus 1.964 and X variable. So we can develop linear equation like this using this regression analysis. So using this equation, we can forecast by study hour, exam score. Then also look at this R 0.62. Last week we talked about the correlation. So 0.62 is not strong, but it has some positive relation, correlation between study hour and exam score. Not much, but there is a positive relationship. So study more hour, then exam score high. So using this regression analysis, we can develop this kind of equation. And by the way, here, this is Y variable, and then this is X variable. So if we have only one X variable, then we call that single regression analysis, because there is only one X variable. But if we have more X variables, then we call that multiple regression analysis, because there are 2 or more X variables. Y is dependent variable, is the response variable, and is assumed to be related to K multiple predictors, multiple X variables independent variables by a linear equation called a population regression model. So looks like this: y equals intercept and plus or minus, depending on the slope. First variable is slope, second variable is slope, and so on. You know, when I was an MBA student, at that time, my major was finance. Then like a capstone course I took, there was no financial market forecasting course. At that time, we used this multiple regression analysis to develop financial market forecasting model. So many cases now we use this multiple regression analysis. So data format generally looks like this. So if there are multiple variables, then usually first column, we set data like this. First column, y variable, and then from second column, x variables. And then n observed variables, the data size n, and, the response variable y, and its proposed predictors, x variables, x1, 2, and so on. And then k is the number of x variables presented in the format, form of n times k. So sample size n, and then k. So we can use still we can use that the basic Excel data analysis tool, but I recommend Megastat. So the data set again, the example data set again. The multiple data example. So it looks like this. And first column, observation, the sample number. So there are 50 sample. And then fat percent, it will be a y variable. So based on age, weight, height, the size of neck, chest, abdomen, hip size, and thigh size. So based on those, then if we can develop multiple regression equation. So I recommend using this Megastat. Then go down to find regression, correlation and regression. And then regression. When we click regression, then it asks input range. So X independent variables, they are or from age to thigh, and then or 50 sample, 50 sample, and then Y variable, fat percent up to that point. Then we don't need forecast, so just the develop the equation. So click OK. And output like this. So using this multiple regression and using a megastat, we can develop like this. From output, we can develop equation y equals intercept negative 35.43. And then first x variable age. The slope is positive, so plus 0.09. Just 2 decimal point I will use. And then x1 plus second x variable is weight, negative. Slope is negative, so negative 0.19. x2. The next one, negative again, so negative height 0.06, x3, and so on. So, oops, where are you? Here. This one, let's see, right. So you can develop all the way. I will not write everything. So x1, x2, x3, x4, 5, 6, 7, 8. So write slope and x1, x2, x3, and so on. So you can develop like this. Okay, then we don't know which x variable affects y variable, how much. Then if they are good to predict y variable, so we need kind of test. Assessing overall fit. We develop multiple regression equation. Then we test if the equation developed well or not. So the equation itself, using F test for significance. Name of this test is global test because we test the equation itself, total equation. So the name of this test is the global test. So for a regression with K predictors, the hypothesis to be tested as like this. So you know hypothesis test. So H0, null hypothesis, all the true coefficients are 0. That means that X variable doesn't work to predict Y variable. And then H1 alternative hypothesis, at least one of the coefficient is non-zero. That means at least one X variable work to predict Y variable. So if after we test this global test, if reject the test result is reject the null hypothesis, then the equation work. If null hypothesis, the test result is do not reject the null hypothesis. That means null hypothesis is true. That case, this equation we developed doesn't work. And then hypothesis, we can write like an word or using symbol B1, slope 1, slope 2, and so on, 0. And then alternative hypothesis is the same. At least one of the coefficient is non-zero. And then same. And then after test, reject null hypothesis if F value, that is the test statistic. I will tell which one is the test statistic later with the output. Greater than critical value. F test, F distribution looks like this, and then all value is positive from 0 to a positive number. So if here F critical value, F distribution, then this one test statistic outside here, then reject the null hypothesis. So F test statistic greater than F critical value, then reject the null hypothesis. Inside, then do not reject the null hypothesis. Let's see. So from the output we did, here, ANOVA table, here, this one, I will make it highlight using this or other color. This one is F statistics, test statistic. So F statistic for this, for a global test, but we don't know the critical value. So data, go megastat, oops, not that one. Go megastat, clear, probability, and then F distribution. Because of the global test using F distribution, click F distribution, then this one asks, this alpha significance level. So usually general research, for general research, we use 0.05 alpha usually. And then this one asks degree of freedom 1, degree of freedom 2 to get F critical value from F distribution, we need two degree of freedom, df1 and df2. Here, from output, df, first one is df1, second one is df2. So you can type just 8, df1, or just click that cell. And then df2 is 41. So click this one. And click OK. It gives us like this. Critical value is 2.17. When df1 is 8, df2 is 41. So test statistic F value is 27.14, way outside. So test result, global test result is reject the null hypothesis. Reject the null hypothesis. So we can say the equation we developed working, that means at least one X variable useful to predict Y variable. But we don't know which one yet. Which X variable is useful to predict Y variable yet. So by global test, we know this equation work, and then now at least one X variable is useful to predict Y variable, but we don't know which one. So to determine which X variable is useful, individual regression coefficient. So individually we test. So individual test, hypothesis H0, beta or B1, 2, 3, 4, 5, slope for X variable. If we test first X variable, then B1 or beta 1 equal 0, beta 1 not equal 0. So, you know, the global test kind of one-tail test, because F distribution is always positive. So only one tail, one side of rejection area. But this individual test, hypothesis is null hypothesis only equal sign. I don't know you remember about the hypothesis. If only equal sign in null hypothesis, that is two-tail test. And then using T distribution. So this is kind of T test and two-tail test. Two-tail test and T test. So T distribution looks like a normal distribution. Two-tail test. There are two rejection areas. So we need plus minus critical value, and then based on where, here, or here, or here, the test statistic, then reject the null hypothesis or do not reject. If test result reject the null hypothesis, that case, this alternative hypothesis true, that means the X variable useful to predict Y variable. Okay, let's see. Go back to the data. Okay, here for age, X variable, test statistic is this one, and X2 test statistic this one. So this column is test statistic for each X variable. And then we need critical value. To find the critical value, again, megastat, and then probability and T distribution. The same significance level is 0.05, alpha is 0.05. Then degree of freedom, this one asks this degree of freedom. Here in output, degree of freedom is 41. So type 41 there. And then this is two-tail, so two-tail test. Then click OK. Then this one gives us critical value is plus minus 2.02. So if test statistic is inside, do not reject the null hypothesis. Outside, here or there, reject the null hypothesis. If that individual test rejected, then the X variable is useful to predict. So go back to plus minus 2.0. Here, test statistic 1.028. Do not reject, reject, do not reject, do not reject, do not reject, 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 do not reject, reject. Do you know what I mean? So if we use megastat, then develop this regression analysis, then megastat indicate by color, bright yellow. Look at this. Reject the null hypothesis individual test. Plus minus 2.0, so 5.5 way outside. So reject the same reject the null hypothesis, but this one is distance from the critical value boundary far, but this one is near. This one is also near. So color is light yellow. Then this one is bright and dark yellow. So go back to this. Actually, this one is R. 0.841. And then 0.841. Yeah. And then this one is 0.917. And then this one is R squared. So when we look at the R score, 0.917. So this equation, very high positive correlation. But if we use only 3 X variables, weight, abdomen, and thigh, only 3 X variables. Let's try. Fat, I will copy this one here. And what was that? Weight, abdomen, weight, abdomen, and thigh variables. Then develop a gain equation using regression, and X variable, only 3 X variables. This one. Why R is lower? Because of die. This one is not significant. So use only 2 variables. Let's go back. Do it again. Regression. X variable, only heights. Oh, no, it was not heights. I did with the wrong, not heights, weights. So Control C. Not heights. So do it again. X variable. And Y variable, the same, okay. Yes, 0.910. Earlier one, A4. Not much different, but still die is no problem. But still, this one is no good indicator. So if you have a multiple data set, and then if you find like y variable and x variables, then using this individual global test and individual test, then you can find the better x variables. So using individual test, then a significant variable just leave, and then take not significant variables out, and then you can make a better equation like this. So using this one, then we can write like a y equals negative 59.0 plus or minus x1, x2, x3, and so on. And then what else? Let me check if it is done. Yeah, I'm sorry. Say again, I'm sorry. You have an individual assignment. So just try, okay? So giving you this individual assignment is let you practice. So try, even if you don't have the right answer, it is valuable, okay? So try, even you don't have a right answer, then I will value you, okay? Okay, that's all. So, do you have any question? So, my research, the second research was predict the total positive cases using the previous data. Okay, so I will try to bring that file. Just a moment. Where that file? So this is my second research paper about the coronavirus. I used regression analysis, but a little bit different, using log linear, because from the data set, data set, we used data, the daily data, and the total data. So up to June 15, we used data from March 1st to June 15. Then this one was not straight. So using log linear, when it is not straight, just the curve linear, then we use log linear. Then we predict, it's like if face mask requirement nationwide. Face mask requirement start when the social distancing nationwide order enacted. And then second one is this one, face mask requirement nationwide if some states, New York, New Jersey, Pennsylvania, Connecticut, and so on, all together, then the total we predict, total case. So we predicted like this: if all nationwide face mask requirement starts in mid April, then this gap, and then if face mask nationwide requirement starts in mid March, then this many and this many less infected. And then we calculate like this. If in April, 694,950 less cases, and then times 0.2, that is the death rate, average death rate. Then 36 less people died. 36,000 less people died until June 15. Then in New York, Columbia University, they forecasted about 30,000. So it's a similar calculation. And then if face mask started in requirement nationwide in mid-March, then 1.8 million people less infected total case, and then 5.28% average in death rate, then about 94,000 people less died. It was our forecasting. So we used regression analysis to develop equation like this. A little bit different from the regular regression, but we use linear regression, then develop the model, and then using model, we forecast like this. So this is a daily case. So daily case decrease like this. You know, New York, New Jersey case similar. So based on this, now we developed a model. So just to show you how we use that regression analysis for research. Any question? So team one, and then team Lydia's team 3, 4. You don't need to develop the forecasting model, but 2 teams data comparing last year and then this year data, right? That case using a hypothesis test. Okay, first develop get data. Let's just team 4 already got data, so that is okay. So for data analysis, I think you need hypothesis test. So when you do that, then ask me, then I will join you, and then I will do it together, okay? And then team 1, 2, okay? And then other teams, based on your research topic, if you get data, then show me. Then I will give you comment which analytic technique you need to analyze your data, okay?
Okay, Dr. Kim.
And then anything, if there is progress, then email me or ask me next class, okay? Then I will give you comment. Okay, any question, comment, complaint, anything? If you have a question or something, then remain. If you're done, then you can leave. Okay, bye.
Bye, Dr. Kim.
Bye, Dr. Kim.
Bye.
Have a good night.
Good night. See you.
Thank you, Dr. Kim. Good night.
Good night, Dr. Kim.
Thank you. Good night.
I have a question, Dr. Kim.
Okay. Stop recording.